Okay, welcome guys. So now I want to look at nth order linear homogeneous equations with constant coefficients. Alright, so far we have looked at second order differential homogeneous equations. Now we want to look at the homogeneous equations with power 3 and more. Right, this is an example of a homogeneous equation because the right hand side is equal to 0. Can you see that? So the other side you have got derivatives, or they are dependent on y, function of y, and then this other side you have got a 0. So that's the example, that's condition for homogeneity. And you are also given, in this example you are also given initial conditions. So these are your initial conditions. They are called initial conditions because your second derivative at 0, which is your initial point, should be 1. Your first derivative at 0 should be 0, and your y at 0 should be 1. So these are initial point because your x values are 0, 0. Suppose your x values were 1 or so, we call them boundary conditions. So boundary conditions are different from initial conditions, that in the sense that boundary conditions you'll be given boundary values instead of initial conditions. Right, so looking at this example, we first find our characteristic equation. So our characteristic equation for this ODE is given by the form m cubed minus m squared plus m minus 1, which is equals to 0. So we're using the trial and error method to find one root of this equation. So let's try minus 1. So when m is minus 1, substitute by minus 1 there. This is minus 1 cubed minus 1 squared minus 1 minus 1. So this is not equal to 0. So this will give you minus 1 minus 1, which is minus 2 minus 1 minus 3. This is minus 4. This is not equals to 0. So this means that m is equals to minus 1 is not a root. So try another one. Try 1. We try 1. This is 1 cubed minus 1 squared, which is 0. 1 minus 1, this is equals to 0, and this implies that m is a root. M is equals to 1 is a root. Then if m is equals to 1 is a root, then m minus 1 is a factor. Then m minus 1 is a factor of this characteristic equation. Now we are left to find two more factors. So since this is a polynomial of order 3, so it means that it has 3 factors. So now we have got one factor, then we need to find 2 more other factors. Right, so if this is a characteristic equation, now we have got one factor, which is m minus 1. Let's try this method. So this means that the other 2 factors will be given by m minus 1 and m minus 1, m minus a, m minus b. So these are the other 2 factors that we want to look for, a and b. Right, so if we expand this, we'll get m squared minus bm minus am plus ab. If we expand this, the square brackets and the curly bracket, this will give us this times this m squared, and then this times this will be minus b plus m. Note that we have factored m, then this is minus b plus am squared times this, which is abm, minus 1 times this, you get this, minus 1 times this, you get plus b plus a m, and then this times minus 1 minus AB. Right, so if you factor out these two, simplifying these two, collecting like terms, so this will give you m cubed minus b plus a plus 1 plus 1 plus the coefficients of a, this is a plus b plus a n minus this one, which is ab. So if we compare the left hand side and the right hand side coefficients, so the coefficient of m cubed, there is 1, so it's 1. And then the coefficient of m squared is minus 1, so this would mean that the coefficient of this is also b plus a plus 1, which is minus 1, which is the same as saying 1 is equal to b plus a plus 1 is equals to 1. Compare the coefficients of m, this is 1, this is a b plus b plus a, which is equals to 1. The coefficient of the constant, which is 1, which is equals to ab there. Not the signs will cancel there, minus ab minus 1. So now we've got three unknowns. We have got two unknowns, which are a and b, and three equations. So this means that we can use these equations to come up with the values of the value of a and the value of b. So the three equations can be used to come up with values of a and b. Right, how then do we do that? If I substitute equation, if I substitute this AB, if I substitute this AB by 1, because from the third equation you can see that AB is equals to 1. So if I substitute AB by 1 there, it implies that I get the same equation as above, because this will be b plus a plus 1 is equals to 1. So this method fails. So for this case, this method fails, then there is need to try and use other methods. So let's try another method. Right, so another method will be, consider these two and these two. So for these two, factorize this. So if I factor out m squared, there I will remain with m minus 1. If I factor out 1, there I will remain m minus 1. So I can factor out m minus 1 both sides. This is what I get, and then I'll remain with m squared plus 1. So therefore it means that m minus 1 is equals to 0, or m squared plus 1 is equals to 0. Then m squared is equals to minus 1, then m is equals to square root plus or minus square root of minus 1. Remember, this is m squared, so solving the equation of m squared should give you two roots. So a square root of any number is equals to plus or minus root of minus 1. So therefore m is equals to, from this one, m is equals to 1, or m is equals to 0 plus remember I is equals to square root of minus 1. So these are your three solutions for that equation. So the general solution will look like this. So you have got a unique number there, which will give you C1 e to 1 x, and then you have got these two, which will give you a complex form, which will be C2 e to the power 0x, this part c cos 1x plus c3 e to the 0x sin x. So note that for this we'll incorporating case 1 and case 3. So simplifying this is what you get. Remember, we have initial conditions, so we need to find, we can find these constants C1, C2 and C3 since we have got these initial conditions. How then can we apply or use these initial conditions? So for initial conditions, you need to find the first, the second derivative. Can you see this? This is the second derivative and this is the first derivative. So you need to find the first derivative of your solution and the second derivative of your solution. Then you substitute for your initial conditions. So if you differentiate this, you get C1 EX. If you differentiate cos, you get minus sine. If you differentiate sine, you get cos. So this is your first derivative. And then your second derivative, you differentiate the first derivative. You differentiate this, still get C1 EX. You differentiate sine, you get cos. You differentiate cos, you get minus sine. So your second derivative will be given as this. So this will be your equation 3. Equation 1 is your solution. Equation 2 is your first derivative. So for initial condition, y at 0 is equals to 1. So x is 0 there. You can see x is 0. And then using equation 1, so we are substituting from y. We are substituting from equation 1 because these conditions, this initial condition correspond to the first equation. So substituting this in equation 1, so this will be 1 is equals to c e to the 0 because x is 0, c1 cos 0, c3 c2 c3 sine 0. So because 1 is equals to c1, 1 number raised to the power 0 is 1, cos 1, use your calculator, cos 0 is equals to 1 and sine 0, use your calculator, is equals to 0. Check that your calculator is in degree mode, because if it's in degree, is radian mode, might get a different answer. So then this will reduce to 1 is equals to c1 plus c2, this one is 0. And then for the initial condition y prime is equals to 0, this is for the first derivative, so we use solution differentiated, which is your equation 2. So using the first derivative, equation 2, this will be, so we're now using equation 2, this one, so this will be 0, c1 e 0, so where there is y you substitute by 0 and where there is x you substitute by 0. So this is 0 0 0 there, so e 0 1, sine 0 0, cos 0 it's 1. So your equation would be 0 is equals to c1 plus c3. Then for your third initial condition, which is y prime prime at 0, this will be 1, substituting on equation 3 because that's your solution differentiated twice. So this will be your solution y prime prime, this will be equals to 1 is equals to, substitute for x 0, e 0, cos 0 and sine 0, and we know that sine 0 is 0, so this solution will be 1 is equals to c1 minus c2. Now you have got 3 equations, which are equation 4, equation 5 and equation 6. You want to use these 3 equations to solve them simultaneously and find the values of c1, c2 and c3. So these are equations c1, equation 4 and equation 5 and equation 6. So solving equation 4 and 6, so if you solve equation 4 and 6, because they have got similar variables, so if you add these two, you add equation 4 and equation 6, you will get this 1 plus 1, you get 2, c plus c, 2c, and then these ones will cancel, get a 0, and clearly you can see that C1 is equals to 1. So if C1 is equals to 1, you can substitute C1 into either 4 or 6, and then you obtain that C2 is equals to 0. So if I substitute this one, C1 1, so this is 1 minus C1, which is 1 minus 1, 0 is equals to minus C1, which is C2 is equals to 0, substituting either there. So we now have values for C1 and C2. Then you can find the value for C3. So your C1 is 1. Using equation 5, your C1 is 1. So this will be 0 is equals to 1 plus C3. So C3 will be equals to minus 1. Now that you have got these constants, C1 is 1, C2 is 0, and C3 is minus 1, you then substitute them from your solution, your complementary solution. Substitute these values for C1, C2, and C3 so that you get your particular solution in the form of Ex minus sine x. So whenever you are given the initial conditions, they are used to eliminate constants from your general solution. So your general solution should not have constant when you are given the initial conditions. Thank you.